Hello everyone, welcome back to the channel. Today we are doing Leetcode 1290, convert binary number in a linked list to integer. So the problem title is pretty much self-explanatory, but still what we are going to do is we are going to have a look at what the problem statement says. It says given head, which is a reference node to a singly linked list, what you have to do is you have to return the decimal value of the number which whatever is present in the linked list. And the most significant bit is actually the head of the linked list, right? So over here I have taken three examples. The first one is 101. So 101, you know for a fact is simply 1 2 4, it's 5 in decimal. Over here the answer will be just 0, and over here it's going to be 1 2 4 and 8. So the answer over here is going to be 9. Now the most simple approach would be, if you think about it, you just have to assign these nodes some sort of weight, isn't it? That's all that you have to do. So once you have assigned these weights to the nodes, all that you have to do is multiply the value. So you're going to have 1 multiplied by 8 plus 0 multiplied by 4 plus 0 multiplied by 2 plus 1 into 1. So that gives you 9. And similarly over here, you're going to have a 1 multiplied by 4 plus 0 multiplied by 2 plus 1 multiplied by 1, which ultimately gives you 5. So the approach is as simple as that. Now the question is how do we actually assign the weights? How do we assign the weights? Assign the weights. If you think about it, there can be a very simple two-pass approach, right? So first of all, what you do is you count the number of nodes that you have. So for example, if I have 1 0 0, what I will do is I will create a temporary pointer which is known as temp, and I will just count however many you can say nodes that I have. So since I'm at temp, I will increment my counter, as in I have one node right now, then I have two nodes, temp comes over here, I have three nodes, and then when temp goes out of bound, when it points to null, that is where I'm going to stop the process, and I'm going to say, okay, at this point I have three nodes. All right, I have three nodes. Now given that I have three nodes, how can I assign the value? Now since I have three nodes, I know for a fact, okay, let's see, is this 2 to the power 3? No, this is not 2 to the power 3. 2 to the power 3 is 8. This is actually 2 to the power 2. So whatever the count value is, just subtract 1 from it. So this is going to be 2 to the power 2. This is going to be 2 to the power 1, and this is going to be 2 to the power 0. Alright, if there was any other value over here, for example, let's say 1, it would have been 2 to the power 3, because count would have been 4 in that case. Right, so it's as simple as that. Let's see how we can replicate this logic inside our coding environment. Let me zoom in a bit and let's see. So first of all, what I'm going to do is I'm going to create a temporary pointer. Sorry, I'm going to create a temporary pointer, and I'm going to assign it a value which is equal to the head of the linked list. Now I'm going to say while temp is not equals to null, I'm going to take a value, a variable, a counter, a simple counter, assign it a value of 0, and I'm going to say, okay, since right now you're at the head, you're actually pointing towards one node, so just do counter plus plus and increment temp, take it to whatever is temp next, right? Temp dot next. So ultimately there's going to be a point where temp is going to point towards the null pointer. Now at this point, I know how many nodes are there in the linked list, right? Perfect. I'm going to again assign temp a value equals to head, and I'm going to now make a variable which is known as answer. Now inside the answer, what I'll simply do is, again I have to traverse the linked list. So I'm going to say while temp is not equals to null, what you just have to do is you have to add into answer some value, and what that value is going to be, it's just going to be whatever is sort of 1 multiplied by 2 to the power count minus 1. So I can say, okay, temp dot val, which is 1 or could be 0 as well, multiplied by what? Power of 2, uh, power of 2, and then what? Count minus 1, right? Power of 2 to count minus 1, and at the same time what I have to do is I have to decrement the count as well, so that the uh, next time, this is this is 2 to the power 2, this is 2 to the power 1, and this is 2 to the power 0, so I have to make sure of that as well. In the end, I just return the answer as it is, and let's see if it passes the example test cases, right? It gives us an error. Why is that so? We have temp dot well, temp is equals to head. Um, why is the error coming? Oh, the error is coming because we forgot to actually increment the temp over here. We need to say temp is equals to temp next. So if I just directly submit it, let's see if it passes all the test cases. Right? And does not. Why? Temp dot. Oh, sorry, it's not going to be a dot. It's actually going to be an arrow. That was a pretty silly mistake. Count minus 1, counter minus 1, and then counter plus plus, right? Counter plus plus. Perfect. Okay, let's see if it passes all the test cases. It does. Okay, pretty simple solution, nothing fancy over here, just a two pass simple solution. And if we take a look at what the time and space complexity is for this particular problem, what we are doing is we are traversing the linked list that we have twice, right? So that's O of n time complexity, and we are clearly not taking any extra space, so the space complexity is just O of 1. So I hope you found the video helpful, and I will see you in the next one. Take care.